Hello everybody, it's Miss Garcia. Welcome to Math City with Miss G. In this video, we will talk about two-column proofs involving CPCTC. What is CPCTC? CPCTC is an acronym that represents the first C, corresponding, P stands for parts, the second C stands for congruent, T stands for triangles, and the last C stands for congruent. So it means corresponding parts of congruent triangles are congruent. We will be able to use this only if when we have proven that the two triangles are congruent using the triangle congruence theorems. And what are these? So we have SAS, which means side, angle side, ASA, which means angle side angle, SSS, which means side side side, AAS, which means angle angle side, and the last one is HL, which means hypotenuse leg theorems. So when we have proven that two triangles are congruent using any three parts of the triangles are congruent and using any of these, then any of the other three remainder parts are also congruent. So this is where CPCTC is being used as a reason to prove that the remainder of the congruent parts of the triangles are congruent. So let me show you how this is being used. Let's try this problem. X is the midpoint of segment WY and VZ. So we're going to write that as our first statement. And our reason for that is going to be given. So when we say that something is a midpoint of a segment, then it will follow that WX is equal to or congruent to XY. So that is actually our second reason. We derive this from the first statement. So segment WX is congruent to segment XY, which simply means that these two sides of the triangles have equal measurements. So our reason for that is this word right here. So the word midpoint is going to explain this concept. So we say definition of midpoint. And we have used segment WY. So then this time we are going to use VZ. And VZ is this segment. And so if X is the midpoint, then it will also follow that VX is congruent to XZ. So that will make our third statement. So VX is congruent to segment V or XZ. Okay, so definition of midpoint. So if you have noticed, we have two congruent parts at this time. So we have number 2 statement, that's the side, they are equal in measure or congruent. Number 3, we also have another side that are congruent. So we need another information. Okay, so remember, we need to have at least 3 congruent parts in order for us to say that the two triangles are congruent. So let us focus on the common intersection, and that is the midpoint. So this midpoint is actually connecting this angle and this angle. So these two angles here form vertical angles. And since it forms vertical angles, that will actually be our fourth statement. So we can start with W. So angle W, X, Y, WXV is congruent to angle, so I should start at Y. So angle YXZ. So these two angles form vertical angles. So then we will say definition of vertical angles. And vertical angles are always congruent. All right, so as you have noticed, we have three congruent parts at this time. And if we focus on what we've got on the illustration, so we have here a side, an angle in the middle, and a side. If we go over on the other figure or the other side, right side, we've got angle, side, angle, side. So then therefore, we can name, or the reasoning for this is that triangle WXV is congruent to triangle YXZ using side, angle, side congruence theorem. And because we already have proven that the two triangles are congruent, then if we go back to the problem, we were to prove that these angles are congruent. And where are these angles in the figure? So these angles are, let's say, X in the middle, then WV. So that's this angle right here. And then this next angle is XYZ. XYZ, so that's this angle. This is congruent to XWV, angle XWV. So then therefore, when there is the fourth congruent parts of the triangles exist that we needed to prove that are congruent, this is when we use CPCTC, meaning corresponding parts of congruent triangles are also congruent. Okay, let's try another problem. In this problem, we are given that we have JM, and let me highlight where JM is. JM is in the center, and so we're going to name JM, or we're going to write that down as our first statement. Bisects angle KJL. So that is given. And when we hear or see the word bisects, this simply means in this case, because it bisects an angle, so a line or segment that divides an angle equally. And so if you have noticed, it says angle KJL. Let us trace where KJL is. KJL. So that is referring to this whole angle. So segment JM divides angle KJL into two equal parts. So that is one of the statements we are going to be writing below. So let us write down the second given first right here. So angle JMK is congruent to angle JML. So let us trace where this angle is. JMK, that's referring to this angle, is congruent to JML. So we are looking at the middle letters. The middle letters is where the angle is. So this one is also given. Now, let us go back to statement number one. We did mention earlier that the segment JM divides angle KJL, then therefore angle, this angle here that I'm trying to color with purple, and that angle is KJM. Angle KJM JM is congruent to angle LJM. So angle LJM. So this angle here is also congruent to angle KJM. And so this one, we derive this answer from number 1. And so we see the word bisect. So we are going to write definition of angle bisector. Okay, so we now have two congruent parts, and this happens to be two angles. So let's focus and go back our attention to the figure. There's nothing else that we can create but trying to focus on what if there is something that is common. And there is actually one. And what is that? We have these right here that I'm trying to color in red, and that is JM. So if we were to split this triangle into two, we will be able to create this figure, and that line or part of the triangle that I color with red, which is this part right here, is actually the same measurement as this. So it is exactly the same. So we can create that as our fourth statement. And that would be segment JM is congruent to segment JM, to itself. And so if we see something like this, that is actually reflexive property. So if we go back to the figure and trying to figure out what triangle congruence theorem is involved, we have angle. We have here an angle, a side in the middle, and an angle. So if I'm looking at the bottom triangle, it is angle, a side, and an angle. So then therefore we can say that triangle JMK is congruent to triangle JML. I'm using this right here, just replace the angle with triangle. So then therefore this would be angle, side, angle, congruence theorem. So we have three corresponding parts. If going back to the figure, we were to prove that segment JK is congruent to segment JL, then this is when, because this is the fourth congruent part, so this is when CPCTC comes in, meaning the fourth, fifth, and sixth are parts of the triangles that are proven congruent previously will also be congruent. So corresponding parts of congruent triangles are congruent. Thank you for watching this video. I hope you find value. Have a good day, and I'll see you in my next one. Bye.